Today, we're going to be learning about the states of matter. Do you know all of them? Maybe, maybe not. Let's just make this video super quick. So without further ado, let's get started. I'm going to start by asking a very simple question you have learned since you were a little kid. How many states of matter are there? That is right. There are 4 states of matter. What? So there are 4 states of matter. So you might know about gas, liquid, solid, but there's a 4th mysterious one. We'll learn about that today. So let's go over the 4 natural states of matter because guess what? There are so many more states of matter, but that are like man-made. So let's just go with those 4 states, natural states of matter. So states of matter are also called phases of matter. A phase is going to describe a physical state of matter. The key word to know this is physical. Things are only going to move from one phase to another by physical means, like if energy is added or if energy is taken away, like let's say increasing temperature or freezing something. If that happens, then you are either adding or taking away energy. And there's going to be a phase change. Not phase, but like P-H-A-S-E, a phase change. So there is this theory called the kinetic molecular theory. The kinetic molecular theory, kinetic means movement. So kinetic means movement. Molecular for molecules, and theory, that it's just a theory, right? So the kinetic molecular theory is going to tell us that the gases consist of tiny, really tiny particles of, really tiny atoms of molecules. So these particles are so small compared to the distances between them that you cannot really see them. So all of these particles are going to be in constant random motion. They go from here to here to here to here. This theory is usually for gases. So the kinetic molecular theory is telling us that gas particles are always moving around and they're moving everywhere in random motion. So let's say a gas particle is moving this way, it crashes onto a wall and then it bounces back. So it's like what? Or it's random motion. These collisions are actually going to affect the pressure of the container that they are in. The particles are assumed to not attract or repel each other or anything, but they could crash into one another, but they're going to just bounce back. Doesn't really matter if they crash onto each other. So gases follow this particular theory, kinetic molecular theory. So they just go random motions really, really fast. They're always moving and they crash, they bounce back again. So nothing really stopped them. Now we talk about the kinetic molecular theory. Let's talk about gases because the kinetic molecular theory is gases. So gases, they have an indefinite volume and shape. What that means is that you cannot really tell what shape it is in, and you cannot really tell how big or small it is because since they are moving so fast and so randomly, you just don't know what shape it is or where they're at or how big it is. So, gases are just there. The atoms in gases are going to move really, really, really quickly. The atoms are really far apart from one another. And since there is so much space in between, you can compress it really easily. Vapor is going to refer to the gaseous state of a substance that is a solid or a liquid at room temperature. That's another thing. So let's say this is a container. Gases are just going to be like all over the place, randomly, like that, and maybe even like this. So they're always like separated from each other. They're social distancing. Liquids, on the other hand, liquids do have an indefinite shape, which means they're going to take the shape of the container they are in, but they do have a definite volume. So by definite volume is that you know exactly how much liquid you have there. But liquids, since they are very, very close together, but there are spaces in between that are going to let them move around. Like here, look at my mole glass. So we have the atoms right there. They are very close together, but they can still move, you know? So they take the shape of the container. They can still slide though, they can still move. But there is very little space in between them, but they can still move along with one another. Solids, they have a definite shape, definite volume. Like, you see a solid, it's, solid. You cannot really change the shape. The atoms are basically stuck together. They're super close together in fixed positions. They won't be able to slide as easily as the liquid one, let's say, or go as freely as the gas one. So, since atoms have to be in constant movement, they're just vibrating there. They're just like, so they're only vibrating. The atoms are packed together in fixed positions. They're not going to go anywhere. And since they're so packed, there's nowhere for them to go. So they're just there. And even if you try to compress it, it's not going to be able to. Look at this, like this. This is super compressed. The atoms are really close together. There's no space in between them. So it's a fixed position. Okay, so if we take a solid and if we add heat, it's on fire, it starts melting, so it becomes a liquid, right? So you keep on adding fire and it starts evaporating, so it becomes a gas. What if you keep heating the gas? What if you keep putting fire onto the gas? What if the temperature of the gas gets so hot? What would happen? And that, my friends, is where we get the fourth state of matter. And it's going to be the most common state of matter in the whole universe. And it's just really impressive how we just didn't think about it for so long. The fourth state of matter. The fourth state of matter is going to be plasma. Now let me ask you this question. If you thought there were only 3 states of matter, solid, liquid, gas, what is fire? Is it a solid? No, because it'll hurt, but you can go through it and everything. It's not like it's packed together. And it doesn't have a definite shape or a definite volume because it can expand, right? And it's obviously not a liquid because it's not taking the shape of the container. It's just like there, just freestanding. And it's not really a gas even though it's fed by oxygen. And it's not a gas because it's not going all throughout the land, it could. What I mean is, it's not separating itself into a bunch of different little things, So they started thinking about that, and they realized that fire is the fourth state of matter. It's plasma. So plasma is like an ionized, it's like a super gas. It's a really, really, really hot gas. Plasma is what you get when you put gas on steroids. No, I'm just kidding. You put a gas on a lot of heat. That's what the sun is. It's plasma. That's what stars are. They're plasma. Have you seen the northern lights? Those are plasma too. So a lot of things in the universe are actually plasma. We just didn't know how to call it. But plasma has always been there for us. Just watching. Waiting for you to notice it. Notice me, senpai. Plasma has always been there. So here's how it goes. We start with a solid, you add energy to it, you come to a liquid, you add energy to it, comes to a gas, you add energy to it, and then it goes to plasma. Plasma is really different and unique from other states of matter. Plasma is different from a gas, although it is like a super gas, because it is made up of groups of positive and negatively charged particles. So it's not naturally occurring on Earth. So that is it for today. I told you it was going to be super short. Here we are. That's all we have right now. Thank you for watching. See you later. Bye. I still don't know how to end this thing. Bye.